So this is the fourth video of all my Java tutorials. That is Java's magic, the bytecode. Doesn't it sound interesting? Yes, it is. So let's begin with it. So the bytecode and what is bytecode? What is the easiest way to create a truly portable code, and what is JVM, and what and how the hotspot technology was introduced. So these will be the few topics I will be covering in the slide. Okay, so let's start with the bytecode. The key that allows Java to solve both the security and the portable problems just described is that output of a Java compiler is not executable code. Rather, it is a bytecode. Okay, that is, bytecode is a highly optimized set of instructions designed to be executed by the Java runtime system, which is called Java Virtual Machine (JVM). In essence, the original JVM was designed as an interpreter for bytecode. This may come as a bit of surprise since many modern languages are designed to be compiled into executable code because of performance concern. However, the fact that a Java program is executed by the JVM helps solve the major problems associated with web-based programs. Here I will explain you why it is and how it is. Translating a Java program into bytecode makes it much easier to run a program in a wide variety of environments because only the JVM needs to be implemented for each platform. That's it. So once the runtime package exists for a given system, any Java program can run on it. Remember, although the details of JVM will differ from platform to platform, all understand the same Java bytecode. If a Java program were compiled to native code, then a different versions of the same program would have to exist for each type of CPU connected to the internet. This is, of course, not a feasible solution. Thus, the execution of bytecode by JVM is the easiest way to create truly portable programs. The fact that Java is executed by JVM also helps to make it secure because the JVM is in control. That is, it can contain the program and prevent it from generating side effects outside of the system. As you'll see, safety is also enhanced by certain restrictions that exist in Java language. In general, when a program is compiled to an intermediate form and then interpreted by a virtual machine, it runs slower than it could run if compiled to executable code. However, with Java, the differential between the two is not so great because bytecode has been highly optimized. The use of bytecode enables the JVM to execute programs much faster than you might expect. Although Java was designed as an interpreted language, there is nothing about Java that prevents on-the-fly compilation of bytecode into native code in order to boost performance. For this reason, the hotspot technology was introduced not long after Java's initial release. Hotspot provides just-in-time JIT, that is compiler for a bytecode. This is the important part. When a JIT compiler is a part of the JVM, selected portions of bytecode are compiled into executable code in real time on a piece-by-piece and demand basis. It is important to understand that it is not practical to compile an entire Java program into executable code all at once, isn't it? Because Java performs various runtime checks that can be done only at runtime, which cannot be done at the compile time. Right, so instead a JIT compiler compiles code as it is needed during the execution. Furthermore, not all sequences of bytecode are compiled, only those that will benefit from compilation. The remaining code is simply, it's just interpreted. Alright, so however, the just-in-time approach still yields a significant performance boost. So even when dynamic compilation is applied to a bytecode, the portability and safety features still apply because the JVM is still in charge of the execution environment. So servlets that are on the server side, as usual, as useful as applets can be, they are just one half of the client server equation. Not long after the initial release of Java, it became obvious that Java would also be useful on the server side. The result was, yes, it's in front of you, that is the servlet. A servlet is a small program that executes on the server side. Just as applet dynamically extends the functionality of a web browser, servlets dynamically extend the functionality of the web server. As simple as that. Thus, with the advent of the servlet, Java spanned both sides of client and server connections. So servlets are used to create dynamically generated content that is then served to the client. For example, an online store might use a servlet to look up the price for an item in a database. The price information is then used to dynamically generate a web page that is sent to the browser. Although dynamically generated content is available through mechanisms such as CGI, that is Common Gateway Interface, the servlet offers several advantages including increased performance. Because servlets are compiled into bytecode and executed by the JVM, they are highly portable. Thus, the same servlet can be used in a variety of different server environments. The only requirement are that the server should support the JVM and a servlet container. So it was a brief introduction of servlets. Alright, so I would be covering in detail in my upcoming videos. So in my next video, I would be covering the Java buzzwords. You might be wondering, what is a buzzword? Java buzzword. Yes, I'll be covering in detail about how Java is simple, secure, portable, how it is object oriented, how it is robust, multi-threaded, architectural neutral, interpreted, high performance, distributed, and dynamic. These all topics I'll be covering in my next video. So for such information and for more Java videos, stay tuned. So let's catch up in our next video. Yes, because before that, don't forget to like, comment, subscribe, and share. If you have any doubts regarding the topic which we discussed, you can just let me know in the comment section below. I will definitely address it. Thanks. Bye bye.